Right, so here's a limit problem, and it's a piecewise function, right? And we witness there are three pieces. 2 minus x, x squared, 2x minus 2. You notice the outsides are both lines, and the middle one's a parabola. They're all polynomials, so it exists. We double check our domain right in here. Less than 2 to negative 2, includes negative 2 to 1, includes 1 to infinity. Guys, every value of x has a function, so it is all real. I do not have to do, and I look, it says the limit as x approaches 2 of h of x, which is one of the, oh shoot. All right, well I made a mistake on this one. Okay, the limit as x approaches 2 of h of x is just 4 minus 2 is 2. I should probably have this problem be set up at negative 2, and that's the way we're going to run. Again, this is just direct substitution. Yeah, shot at 1. So we'll do it this way now. We'll go negative 2. All right, so every time I'm going to do 2 before I do 1, because the justification is always the same way. If a limit exists, what do you know about the left and right hand?
They collide.
They are the same, they collide, they're the same. And if it has a solution, they'll be the same, and if it doesn't, they'll be not the same. So I can do 2 before I do 1, and I can have that lead me to the answer. So the first thing I'm looking for, oh, it's all one thing, can't move it. First thing I'm looking for are the right hand and left hand the same. So I would do the limit as x approaches negative 2 from the left hand side, and I would do the limit as x approaches negative 2 from the right hand side. Now, from the left hand side, that's when x is smaller. So this, from the left hand side, I would actually erase this and put in 2 minus x. And 2 minus a minus 2 is positive 4. If I look at the piecewise function and I'm coming at negative 2 from the right-hand side, you guys see it's coming from 0, right? So this is just x squared, but negative 2 times negative 2 is 4. So the answer to this problem is 4, and the justification is the left hand and the right hand are the same. Yeah, the justification is just that the left hand and right hand are the same. Exactly. And that's it, but it comes down, we justify limits by their hands. We prove limits using precise definition of limits. That is much more complicated, right? That is from section 2.4. Where we show a relationship between epsilon and delta. We'll do that later. That's a proof. This is justified. It's different. All right. So for the nenext one, I want you to, if it was here, I'll do it in red instead of purple. So I'm going to do the limits as we approach 1. When I approach 1 from the positive side, it's going to be that function, right? The 1 to the right. And I'm going to see that that's 0. When I do the limit from the left-hand side, it's x squared, and I'm going to get 1. So for number 3, does not exist, right, is the answer. Why? Because the left hand is 1 and the right hand is 0, and they're not the same. So the justification is the left hand does not equal the right hand. Yep. Thank you. So we're justifying the limits. Everybody, you don't need a graph. 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 That said, let's graph it. Because sometimes students can't see what we just did. All right, and that's fine. We'll shrink that down. They can run the video and be in reverse to see it. Get all this crap out of here. All right, we'll go to 100%, and let's graph this real fast for the video. There's y. There's x. I will do the first part of it in green, negative 2. I know if I plug negative 2 in, it's 4. 1, 2, 3, 4. It's not equal, so it's open circle. Negative x plus 2. It's going to go through 2, but it's going on a slope of 1. And I could picture the line. It would have gone through 2. right, and bend the line, but I'm only from less than equal to -2. Next one I'll do in red. X squared from -2 is equal. -2 squared is 4. It fills in the green circle. 1, 1 is open. Goes through the origin. Boom. That's the middle one. And the last one in black, 2x minus 2. At 1, I plug in 1. I know it's 0. Solid dot because it's equal. I can picture the line going to the right, slope of 2. Up, up, and away. And now it's pretty obvious, right, when we look at -2, that there's a limit. And it's really obvious that there isn't at 1. What do we know about anywhere else on this function? It exists. Because the three functions, the green one, the red, and the black, are all polynomial continuous functions. Direct substitution everywhere else. Direct substitution everywhere else. Keep practicing. Calculus is fun.